Assalamu alaikum. My name is Dr. Asad Mehmood Khan. Currently, I'm working as a PGI in the unit-2 of the LGH. The topic which I'm going to present is parameters of the YAG laser. Before discussing my main topic, I will discuss few aspects regarding the YAG laser. What is the basic principle of the YAG laser? YAG laser is a neodymium-based laser, which stands for ND stands for neodymium, while the YAG stands for yttrium, aluminium, and the granite. It's a 4-level solid-state laser. Now, the active medium of the ND-YAG is basically the optic medium of this laser is the ND-YAG, and it is optically pumped by the krypton. What happens that this krypton will provide optical pumping to the laser rod. In the laser rod, our active medium is present. This active medium will stimulate from its base level to the energy level 4. Now, there are 4 levels of the energy 4, 3, 2, and 1. 4 and 3 are the excited states, and the 2 is the metastable state. What is the metastable state? In that, the emission of the photons will happen, and the electrons will move to E naught, but they will do it very slowly. In excited state, the spontaneous emission is very rapidly, because in that the slow progression to E naught state. So that is why we call it a metastable state. The thing which I have explained is basically explained in this diagram. E naught is the basal level, E2 is the metastable state, E3 and the E4 are the excited state. Initially, krypton flash tube will provide energy. Electrons will move from E naught to the E4 state. From there, there will be spontaneous emission, and then they will retain in the metastable state. When the electron will move from the metastable state towards the E naught state, they will emit the laser waves. What happens that initially the number of photons are multiplied basically in that. In the previous diagram, we can see that there are 2 mirrors. One is the fully reflecting mirror and the other one is a partially reflecting mirror. The photons will vibrate between these 2 mirrors until our desired level of the energy is achieved, and they are emitted in the form of the laser. This is the basic working mechanism. Now, what are the characteristics? It is a 4-level solid-state laser. Active medium is the ND-YAG. Pumping method is optical pumping, which is done by the krypton laser, which is source. There are 2 ends of the YAG rods, which is polished by the silver. One is fully silvered, and the other one is partially silvered. Are used as an optical resonator. The power output is approximately 70 volts. The nature of the output is pulsed or continuous. We usually prefer most of the in ophthalmological procedure, because ND-YAG is not only used in the ophthalmology, it is used in some other aspects also. But in ophthalmology, we mostly use the pulse method. Now, what are the parameters? Working substance ND-YAG, laser wavelength is 1064 nanometer, pulse energy is up to the 7 joules from 1. Laser pulse width is 9 to 21, spot size is circular, and the spot diameter is 1 to 5 millimeter. In iridotomy, we usually prefer the energy of 3 to 8 millijoules. In photomydriasis, 4 to 6 millijoules. In the chorioplasty, it is basically centralization of the pupil. The energy we usually require is the 8 to 9 millijoules. In the hyperplastic pupillary membrane, 1 to 1.5. And tear hyaloidectomy, which is usually done in the malignant glaucoma to dissect the hyaloid, for up to the energy is about 1 to 2 millijoules. Cyclophotocoagulation, it is again used in the malignant glaucoma. We will ablate our ciliary body because it is the source of the aqueous, and the energy source is 4 to 8. Posterior capsulotomy, most commonest procedure done in LGH. The energy required is 1.5 to 2. Sweeping is basically whenever there is pigmentation of the IOL. This is known as sweeping, and the energy is about 0.5 to 1.5. And the corticolysis, whenever there is a retained cortical lens matter, we dissolve it with the help of the YAG laser, and the energy level is about 4 to 5 millijoules. Now, this is the end of my presentation. Thank you very much.